Hey guys, Zulk here. Welcome to the second channel. As with every video, I need to get this disclaimer out of the way to not waste anyone's time. If you clicked on this video expecting to learn something about C++ in any efficient manner, maybe you needed C++ as quick to do something, maybe you wanted to know how to do a certain thing in C++ for a project or whatever, and click off now because this video is not that. This video will not teach you very well how to do stuff in C++, not in a timely manner. So I suggest you find a better tutorial somewhere and good luck with whatever it is you need to do with C++. With that disclaimer out of the way, let's get started. So last time I spent 4 freaking hours downloading stuff like MingGW and code blocks, and yeah, I have 2 instances of this thing now on 2 places on my computers because I fucked up installation, and I'm just going to ignore one of those, go right into code blocks. What was, did you guys see that? There was some weird glitchiness going on over here. I don't know what that was. Oh, I should open this up. Sorry, I got lost in my own head for a sec. Sorry about that. Open up google.com over here. And I'll just leave that there for if I need to look something up. For now though, opening up a new empty file. Let's go ahead and save this as a C++ file. Oh, C and C++. Is there anything else I need to worry about? No, just C and C++ file. So it's there already. I can overwrite this because that one was just a hello world program just to make sure that this thing here worked. So yeah, I am now going to open that book and finally start reading. Again, this series is gonna have a shit ton of dead air as I read this book. I will read out 1 or 2 lines, not the full thing. I'm gonna read out 1 or 2 lines, which I think is important. So, and most of it is just gonna be me sitting quietly reading it. So let's get started already. Oh, and this is that book. I talked about it in the first episode. It was Teach Yourself C++ by Herbert Schlitt. And I think this is the first time I'm reading this on camera. While everything what's it says down here, while everything that you know about the C language is fully applicable to C++, understanding its enhanced features will still require a significant investment of time and effort on your part. Okay? The purpose of this chapter is to introduce you to several of the most important features of C++. Okay? It is difficult to discuss one aspect of C++ in isolation because the features of C++ are highly integrated. Okay? To help overcome this problem, this chapter provides a brief overview of several C++ features. This overview will enable you to understand the examples discussed later in this book. Okay, so I guess I should read this chapter then. At the time of this writing, the standardization of C++ is being finalized. For this reason, this chapter describes some important differences between versions of C++ that have been in common use during the past several years and the new standard C++. Since this book teaches standard C++, this material is especially important if you are using an older computer. I am not using an older computer, but I should give it a read anyway. This book, when was this book written? In 2017 and 18. This edition. Oh, it said older compiler, not computer. I don't know if Ming GW is an older compiler or not. Before you begin, I think this part is important. Before you begin, a few general comments about the nature and form of C++ are in order. First, for the most part, C++ programs physically look like C programs. Like a C program, a C++ program begins execution at main to include command line arguments. C++ uses the same argc argv convention that C uses. So argument constant and argument variable, I guess. Although C++ defines its own object-oriented library, it also supports all the functions in the C standard library. C++ uses the same control structures as C. C++ includes all the built-in data types defined by C. This book assumes that you already know the C programming language. I actually do know C. I haven't used it in like 5 years or something, but I do know it. I did learn it. I learned it pretty well to the point where I made a text-based adventure game in C. It was very basic, done. It had no graphics. It was done fully in the command line, and it conveyed to you in the form of written text, like printed text. So it wasn't really that impressive, but I did manage to make a game like that. I lost the files, by the way. It was in a very, very old computer. This book assumes that you know how to compile and execute a program using your C++ compiler. If you don't, you will need to refer to your compiler's instructions. Since programming is best learned by doing, you are strongly urged to enter, compile, and run the examples in the book in the order in which they are presented. Okay, so that is something we'll have to do then. What is object-oriented programming? That's the next, uh, that's the first topic, I guess, sub-topic in the chapter. No, topic in the chapter. Object-oriented programming is a powerful way to approach the task of programming. Since its early beginnings, blah, blah, blah. Okay, this just talks about the history of programming languages, like as a whole, the evolution of programming languages. Oh, I think this is something I should always keep in mind about. By using high level language, a programmer was able to write programs that were several thousand lines long. However, the method of programming used early on was an ad hoc anything goes approach. That's how I wrote most of my programs actually. While this is fine for relatively short programs, it yields unreadable and unmanageable spaghetti code. Yep, that's the problem I faced as well when applied to larger programs. The elimination of spaghetti code becomes feasible with the invention of structured programming languages in the 1960s. I need to get good at this. I need to get good at coding without cooking up spaghetti in text form. Oh, wait, I think I misunderstood what they said about spaghetti code. Structured programming relies on well defined control structures, code blocks, and the absence or at least minimal use of the go to. Oh, so that's what they meant by spaghetti code. No, I didn't do that, but there was really what I did with my code was whenever I needed a function, I just wrote it. And even though the programming language might have been structured, there was no rhyme or reason to the variable naming, to the to order in which things appeared outside of the order they needed to appear in for the compiler to read them properly. So yeah, I programmed in Python by the way. And I used a fuck ton of if else statements. Using structured programming, the average programmer can create and maintain programs that are up to 50,000 lines long. Damn! Wait, although structured programming has yielded excellent results when applied to moderately complex programs, even it fails at some point after a program reaches a certain size. To allow more complex programs to be written, a new approach to the job of programming was needed. Towards this end, object oriented programming was invented. Object oriented programming, or OOP for short, takes the best of the ideas embodied in structured programming and combines them with powerful new concepts that allow you to organize your programs more effectively. OOP encourages you to decompose a program into its constituent parts. I need to get good at that. Each component becomes a self contained object that contains its own instructions and data that relate to that object. In this way, complexity is reduced and the programmer can manage larger programs. All OOP languages, including C++, share three common defining traits: encapsulation, polymorphism, and inheritance. Let's look at these concepts now. Encapsulation is the mechanism that binds together code and the data it manipulates and keeps both safe from outside interference and misuse. What does that mean though? In an object-oriented language, code and data can be combined in such a way that a self-contained black box, oh, I know what that means, is created. Basically, instead of worrying about what is happening to the data, a black box style of programming is basically you create like a sub program, a method to be specific. Like you create a method which accepts a variable, does its thing to the variable, and then spits out the desired output. Takes input, does shit, spits out output. And at a and while you do need to write the method, what exactly it's doing and how, you need to write that if you're the only programmer present. But in general, in a broader sense, you don't really need to know. You don't need to worry too much about what is going on. All you need to do is have a method, put data into the method, and get the data you want out of it. I think it's basically you write a bunch of methods like that and call them into your main program as it's needed. I think that's how you do it. I'm not 100% sure on that. Don't quote me on that. When code and data are linked together in this fashion, an object is created. In other words, an object is the device that supports encapsulation. Within an object, code, data, or both may be private to that object or public. Private and public in this case means, can stuff outside that method access that data? If yes, then it's public. If no, then it's private. I think that's how it works. Private code or data is known to and accessible only by another part of the object. Yeah, it says so right here in the book. That is, private code or data cannot be accessed by a piece of the program that exists outside the object. Exactly. When code or data is public, other parts of a program can access it, even though it is defined within an object. Typically, the public parts of an object are used to provide a controlled interface to the private elements of the object. For all intents and purposes, an object is a variable of a user-defined type. Each specific instance of this data type, each time you define a new type of object, you are creating a new data type. Each specific instance of this data type is a compound variable. Okay? I think I understood what that meant. I think what they're saying with that line is, let's say I want to make a calculator program. I create a function called add. I will pass two numbers to that function and it will just add them together and give me the output. In which case, the what was I? Oh yeah. In this case, the add function itself is a data type, I think, here. And each instance I create of that, like if I define in a, if I define like function a which just does the add thing, then that is a variable of the add type. I'm not explaining it well. I am not explaining it well, but I think I kind of get what they're saying. We'll learn this more as when we start doing the examples ourselves. Yes, I am going to do the examples. I'm trying to learn C++ here. I don't know what I'm doing. I don't have experience with C++. I'm just trying to master it. Polymorphism. Polymorphism is the quality that allows one name to be used for two or more related but technically different purposes. As it relates to OOP, polymorphism allows one name to specify a general class of actions. Within a general class of actions, the specific action to be applied is determined by the type of data. What? I need to read that again. Polymorphism allows one name to specify a general class of actions. Within a general class of actions, the specific action to be applied is determined by the type of data. For example, in C, which does not significantly support polymorphism, the absolute value action requires three distinct function names: abs, labs, and fabs. These functions compute and return the absolute value of an integer, a long integer, and a floating point value, respectively. However, in C++, which supports polymorphism, each function can be called by the same name. Oh, I get it now. Same name such as abs. Basically, the function gives you different output based on what kind of data you put in. If you put in a character, it would input one kind of data as an output. If you put in a number, it would input a different kind of output. But it's still one function. One function, one name. And thus that is polymorphism. I think I get it now. The type of data used to call the function determines which specific version of the function is actually executed. It says here, another thing it says right here, it is possible to use one function name for many different purposes. This is called function overloading. Interesting. I'll keep that in mind. Polymorphism can be applied to operators too. Virtually all programming languages contain a limited application of polymorphism as it relates to the arithmetic operators. For example, in C, the plus sign is used to add integers, long integers, characters, and floating point values. In these cases, the compiler automatically knows which type of arithmetic to apply. Interesting. This type of polymorphism is called operator overloading. I see. The key point to remember about polymorphism is that it allows you to handle greater complexity by allowing the creation of standard interfaces related to activities. Ah. Inheritance. I actually know very well what inheritance is. Inheritance is the process by which one object can acquire the properties of another. More specifically, an object can inherit a general set of properties to which it can add those features that are specific only to itself. I learned a lot about inheritance from trying to make custom weapons and armors and monsters. Well, I didn't make any more custom monsters, but weapons, armor, and what else did I make? I made weapons, I made armor, I made ammo types for my Doom maps. So I had to know what I learned what inheritance was from that. In each case, the child class inherits all those qualities associated with the parent class and adds them to its own defining characteristics. Without the use of ordered classifications, each object would have to define all characteristics that relate to it explicitly. Yeah, it stops you from having to define the same function, same variable, same shit over and over again across many different functions. The advantage of inheritance. Okay, here's some examples. Encapsulation is not entirely new to OOP. To a degree, encapsulation can be achieved when using the C language. For example, when you use a library function, you are in effect using a black box routine, the internals of which you cannot alter or affect, except perhaps through malicious actions. Consider the fopen function. That's the file open function, isn't it? When it is used to open a file. Yep. Several internal variables are created and initialized. As far as your program is concerned, those variables are hidden and not accessible. However, C++ provides a much more secure approach to encapsulation. In the real world, example of are quite common. Yeah. They have an exercise here at the end of this topic. Think about the way classification and polymorphism play an important role in our day to day lives. That is not directly related to programming, so I will not do that exercise. Plus, I think I did that way too many times already. Not the polymorphism, the classification part, when I had to study for biology in high school. So, yeah. Two versions of C++. That's the title of the next topic. At the time of writing this, C++ is in the midst of a transformation, as explained in the preface of this book. C++ has been undergoing blah blah blah. The first is the traditional version that is based upon Bijan Strauss. I don't know how to pronounce that name. Hold on. This is that name. I don't know how to pronounce that. Oh, I even wrote his name wrong. Strauss. Trup. Jarn Jarn Traustrup? Is that how you pronounce it? Jarn Traustrup? I don't know, this guy. I'm gonna call him Johnny. Oh, Johnny's original designs. This is the version of C++ that has been used by programmers for the past decade. The second is the new standard C++, which was created by Johnny and the ANSI/ISO standardization committee. I see. Standard C++ contains several enhancements not found in traditional C++. This book teaches standard C++. Good. Standard C++ is the version, the ANSI-ISO version. It is the version implemented by all modern C++ compilers. I wonder if MGW does that. I think it does. If you are using an older compiler, it might not accept all of the programs in this book. Here's why. During the process of standardization, the dash ANSI ISO committee added many new features to the language. As these features were defined, they were implemented by compiler developers. Of course, there is always a lag time between the addition of a new features to the language and the availability of the feature in commercial compilers. Since features were added, okay, so that's why. Basically, eh, when they were standardizing C++, they added a bunch of new features. It didn't reach all the devs. And if you're using a really old compiler, it doesn't have that feature added. It's honestly kind of like playing an old version of a game. Like some things get changed, some things get added, some things get removed. There are differences. between versions of everything. Two recent additions to the C++ language affect every program that you will write, even the simplest. If you are using an older computer that does not accept these new features, don't worry, there's an easy workaround which is described in the following paragraphs. The difference between old style and modern code involves two new features, new style headers and the namespace statement. To demonstrate these differences, we will begin by looking at two versions of a minimal do-nothing C++ program. The first version shown here reflects the way C++ programs were written until recently. That is, it uses the old style coding. Let's try this actually. So this is a comment, a traditional style C++ program. I'm just going to show it here. Uh, Sorry. When you do this, this is basically a comment. This is a comment. Compiler won't do nothing with stuff between in comment. This is also a multi-line comment. I forgot how to do single line comments. Like this maybe? Is this a single line comment? I don't know, probably. I think this is it. Let me actually double check. How to write comments in C++. Yeah, two slashes. I remembered that from C. Now, let's write it. Hashtag include io stream.h. Okay. Then int main. That's the main program body. It says so right here. Program code. It says write the program code here. So just to see if it works or not, I'm going to use printf. Printf hello world. That's the program code. Return 0. In C++. Let's see if this actually works. Build and run. That's not good. Why isn't iostream? No such file in directory. Hold on. stdio.h works. So why not iostream? This is the first problem I encountered now. iostream not file not found. I just updated my blah blah blah. I tried to command line program, but I had a problem which didn't exist. iostream. What? Okay, I may have an idea of what might have gone wrong here. Compiler. Where is the header? Do I need to hang on? What happens if I go and do this? No, not inside code blocks. No. If I use this, okay, try and build and run. This still works. Wait, did the file path? File path is correct. IOSTREAM .h. What the fuck is going on? See. minggw.h. Hold on, is stdio.h in here? stdlib stdio.h, it's here. IO stream is not here though. IO.h is here. What? IO stream missing in not found in GCC. At all, I got some. Hold on. Use G++ instead of GCC. Compiler. Is there a G++ compiler somewhere? G++ compiler. Yeah. How do I tell? Compiler settings. Hold on. What happens if I try and do this? Still doesn't find it. Is something wrong with this place? No. Going back here. CP. Hold on. Cancel. Wait. Go back. Okay. Now. Save as. What happens if I do this? No, not dot C. What happens if I try and make an empty file and then save the empty file as CCP? No, CPP, right? Yes, CPP. Dot CPP. Hold on. Save file as CPP. Yes. Does it work now? No, it still doesn't find, even with that, it still doesn't find it. No file, IO stream missing. This isn't making any sense to me. Live exec. No. Hold on, I have a plan. Let's go back to program file. Search program files. Does any is this thing in anywhere? iostream.h. No items match your search. What about stdio.h? We have plenty of stdio.h's, no IO streams. What about IO stream? Just IO stream. It's somewhere here. Where is this? Code blocks, mean GW, library, GCC. Code blocks, mean GW, library, GCC. In here, library, no. In it, include std int std is stdio is iostream in here somewhere. Maybe I'm in the wrong place. Include fixed? No. Okay, I know that it's in here somewhere. Search iostream in, where is it? Mean GW, then lib, then GCC, then this, then 8.1, then include, then C++. Wait, what? Code blocks, lib, okay. Lib, then GCC, then this, then include, then C++. There you are, there's iostream. What file type is this? Is this it? Is this a header file? View. It says show file name extension. It's not telling me what file name this is. Okay. Settings, compiler. Toolchain executables. Search directories. Resource compiler. What happens if I add? Not here. Code blocks. What happens if I just put the whole thing in here? Fuck it, also put that there as well. Why not? Okay. Now, do you find anything? If I remove the .h, do you find it now? I know there's an IO stream. Hang on. Compiler. And if I remove these things, yes. Do you have trouble finding it still? No, you don't. So I guess for whatever reason it was listed as iostream and not iostream.h. Weird. I need to check that out actually. iostream.h missing, but iostream is not is found. Parallel. First of all, devc is not a compiler, it's an ID that is blah blah blah. The ID hashtag include iostream instead of iostream is not a standard header file. If anything supports it, it's for backward compatibility from long ago. None of the header files introduced in C++ have an extension. The same goes for fstream and fstream.h as well. I see. What happens if, since this is a C++ file now, what happens if I do this? stdio, stdio, not the .h. Of course, that is not found. iostream. No, not .h. iostream is there, but iostream.h is missing. I don't know what that's about. I honestly don't. Let me pull this up again. What's in here? So apparently nothing has the .h stuff. Interesting. But these things have .h with them. But I guess these are for C and not for C++ then, right? Is stdarg for C++? Let me ask that. I closed that. I closed Microsoft Edge. Google.com. Is, what was that file name again? Is stdbool. I'll go with stdbool. Is stdbool in C++? C does not define a boolean type, but the compilers generally do define something like bool dot in case of C++ at C mixed, including stdbool.h defines bool as a C++ bool. Huh? It is important to note that in C, a boolean is most likely a type of value. C does not define a boolean type, but the compilers generally do define something like bool. Turns this into bool and defines true and false in terms further. In case of C++, G defines dash bool as C++ bool. So a lot of these are for compatibility with C. Let me try something. Hashtag include what was that name again? std bool, right? std bool .h. I've noticed something. If it's there, if it's there, I don't have to worry about whether I have to put .h or not, because it's gonna help me. The IDE is going to help me with that stream. Okay. So I learned another thing today. I learned that sometimes you don't need to put .h. A modern style C++ program. Oh, that was a traditional style C++ program. Since there's more, I should have read the book more. Look at this. A traditional style C++ has to iostream.h int main program code. Since C++ is built on C, this skeleton should be largely familiar, but pay special attention to the hashtag include statement. This statement includes the file iostream.h, which provides support for C++'s iostream. It is to C++ what stdio.h is to C. Here is the second version of the skeleton, which uses the modern style, that uses the new style headers. Hashtag include iostream, then hashtag include iostream using namespace std, then int main. By the way, std in case of C and C++ does not mean sexually transmitted disease. It stands for standard as far as I know. Okay, namespace std still works. Notice two lines in this program immediately after the first comment. This is where the changes occur. First, in the hashtag include statement, there is no .h file in the blah blah blah. And second line specifying a namespace is new. Although both the new style headers and namespace will be explained in detail later in this book, a brief overview is in order now. The new C++ headers. I really need to read this because I think I just spent 20 minutes of my life getting confused by headers. Here it is. I really should have read this. Standard C++ has introduced a new kind of header that is used by the standard C++ library. The new style headers do not specify file names. That's why I couldn't find file types. Instead, they simply specify standard identifiers that might be mapped to files by the compiler, but they need not be. The new style C++ headers are abstractions that simply guarantee that the appropriate prototypes and definitions required by the C++ library have been declared. Since the new style header is not a file name, it does not have a .h extension. Such header consists solely of the header name contained between angle brackets. iostream, fstream, vector, string. The C++ versions of the standard C headers simply add a C prefix to the file name and drop the H. For example, new style C++ header for math H is CMath and one for string H is CString. Although it is currently permissible to include a C style header when using C library functions, this approach is deprecated by the standard C++. This is not recommended. For this reason, this book will use new style C++ headers in all hashtag includes. Ow. Sorry about that. I got excited and accidentally karate chopped my headphone wire. Let me try some weird shit here. This is something I do when I'm just. This is not something I do when I'm trying to make a code for something. This is more something I do when I'm trying to understand something. I purposely test out what I know to be what I think is highly likely to be faulty code just to see what kind of error happens. Hashtag include, let's see, string dot h. So string dot h is found, and hashtag include c string. I see. I know what to do going forward then. As of writing this, all C++ compilers support the old style headers. Are you sure about that? I just ran into an error. Maybe I installed my compiler wrong. I don't know. However, the old style headers have been declared obsolete and their use in new programs is not recommended. This is why they are not used in this book. Well, still common in existing C++ code, old style headers are obsolete. So what have we learned today? We learned that for whatever reason, when I installed code blocks, it did not come with any of the old style headers. It did not come with any iostream.h, and attempting to use iostream.h, it gave me multiple errors and my program wouldn't run. That's what we learned today. I think I'm done here. I think this is a good place to stop. Not only has this video been 1 hour long, I feel like just the lesson that iostream.h does not work is important enough. Well, it is for me. I am a dummy. You are smarter. For you, you probably could have learned more today if you were me, but you're not me. I'm an idiot. This is enough for me for one day. I'll pick this up again tomorrow, perhaps. In the meantime, let me get a pen actually. Normally, I don't like marking books. The last time I marked a book was when I was still in high school and I had to underline it. No. I did it in college as well when I had to underline a bunch of stuff for important information. Here, though, I'm just marking it that, hey, this is how far I've read. And this is where I need to pick off as a bookmark. I marked under namespaces, I marked beside namespaces, and that's where I'm gonna pick off in the next episode, I guess. So let's do something fun. Yes, save changes. Okay, we are playing chess here, and I did something interesting. Hold on. Okay, so I tried to inspect element Q to remove my opponent's name and shit, so I didn't have to edit this video. But sadly I failed, so now I have to edit this video. I'll put the censor bars up there like usual. But for now, I am playing a 763 rated guy from Scotland. My rating is 821. He's starting with the queen's pawn. So I think this is something I'll do. I'll play a game of chess at the end of every video. I needed a drink. Okay, so he's doing that. I am going to move my bishop out. Since this pawn is safe for now. Okay. Move this knight there. Let me just make my position better. He wants to come here, I think. Do I want to move my... I think I want to move this knight here. I'll move this other knight here. I think he's going to push in the center. Fine by me. I have more than enough stuff to deal with that. I am going to push the queen up though. Actually, I'm going to push the bishop up first. Move the queen here. Okay. Was that a mouse slip, or is this some kind of... Is this some kind of move that I don't know about? It could be possible. It could be a book move or a line that I don't know because I'm not that good at chess. The 821 rating should be more than enough indication of that. He's trying to take this. And he can come here to attack the queen. If I move this, no, he can't. Because this square is currently being guarded by the knight. So he's trying to take this still. I'm gonna push this up. Force his knight to move. He can of course move here and attack my bishop. That is something he can do. Oh, he was trying to attack. Can't I block this with a pawn? I mean, this one is still being guarded. I guess he can move it like this. I can take with knight. He can take with... Wait a minute. I move pawn to block. He takes with knight. I take back with knight. He takes this. He wins a pawn. Ah. Interesting move. I am going to move my knight here then to block that. Then I'm going to castle king side. Yeah. What are you trying to attack here? You're attacking my queen. My queen is trapped. Well, it would have been trapped. But it does stop me from castling, unfortunately. Okay, things are getting dicey. I can't move my king. I need to get rid of this guy somehow. How am I going to get rid of this guy? Okay, this is guarded so far. Push this. But no, if I take then this, that's not good. And if I don't take, then yeah, things aren't looking too good, guys. If he takes, I can't take back. Because then the queen takes. Oh, oh. Spaghetti-o. Yep. But wait. I, your bishop is trapped now. I can move, right? But then you... But then you move your knight. And put a check on me. I need to defend this. I need to put something between... Wait. What if I go here, attack that way? You can't take back. And even if you move your knight somewhere, this knight is still protected by this knight and protected by the king. So the queen can't just run in and take. And if you try to move your bishop, I take your queen. I'm spending way too much time in this. You know, I think I should move this pawn at some point to allow my queen to get out just so my king can castle. Because this rook is pretty vulnerable right now. What was the point of this move? I'll take with the rook so I can attack your queen. You can't take back, because if you do, then I take. I guess you can move there. That's pretty safe. No, you can't move there. Perfect. Absolutely perfect. Oh, you moved there to prevent my knight from going here. Interesting. And this knight can't go anywhere. Let me move this bishop here so I can attack your queen again. You can't go here or here. You have to go back. Or here. Here is good too. Not there. Queens can move in all shapes. Here and here. These two squares are good. Every other square is dead. Here is also good, I think. Yeah. These three squares are good. Every other square is dead. Perfect. I think I've regained some momentum. I won a bishop somehow. How? Don't ask me. Don't ask me how. So now I think I should start finding a way to get my queen out and have my king castle. This moved down. This is coming next. I can sense it. If that is coming, I'm going to push this. It traps my bishop. But if takes, then this. So you can't take. What is the point of that? Oh, to guard the rook. If I take, this is bad. Take, take, take. Let's say I take, lose this. He takes with rook, lose this. I take back with my rook, lose this. And he takes back my rook. It's an even trade and his queen is in a bad spot. So I am just gonna leave that there. Wait, what's defending this knight? Absolutely nothing. If I do this, this takes. Then I can move my bishop here. But then he can slide the rook down here and deliver a brutal check. Why can't I move? That is checkmate. That is 100% checkmate. If I take this knight, This is a poisoned knight. If I take this, then this, then I am just screwed. Because then no matter what I do, this is coming and I have no way to stop that. So in that case, let's just forget that thing exists and simply develop. How do I develop? Oh yeah, I wanted to castle, didn't I? I completely forgot. Oh, I see a weakness. Move this here. Then I can attack this. I am running low on time. He's probably going to push this down. But then I can bust open the center. Interesting. But that means this place is no longer guarded. I can move there. I'm not sure what exactly that does. Or I can move here and take this way. Yeah, I think I like that idea more. Attack this. Oh wait, I still wanted to castle, didn't I? Okay, I guess now I have no choice but to do this. I was going to delay it one move to castle, but you forced my hand. Now your queen is under attack, by the way. So you've got to move. Where can you move actually? Over there. Perfect spot. Now this would have been a fork, but oh, you guarded this. Interesting. And you're attacking my knight. I have a plan. This is the greatest plan. You can't take my knight or my bishop because they're protected. I just saw something. If I can somehow, yes, if I move my knight back, I'll be guarding this square. Then if, oh, come on, man. Uh, but wait, this board state is a bit different because now, if I move back here, my queen is guarding this knight. Then I can move back here next turn. I can take. I'm gonna do this fancy gimmick. I'm gonna move back. And on the next turn, I am going to move my bishop here. Ooh, he saw it. Damn. Well, I can at least move my queen. Hello. I saw something magical. I take this. He takes with queen. I move my knight here to attack his queen and his rook at the same time. Perfect. Now take back with queen. Come on. I know you want to. Otherwise, you're going to have to move a rook, or that would have been a loss of a knight. I don't usually play chess this good. Normally, I play much faster, even on 20 minutes, and I lose. That's why I am 821 rated. I can still attack this queen at least next turn. Perfect. Now before I do that, nope, my knight is guarded. Take that. Well, there is one thing you can do. You can move this here to attack my queen. But then I just move up here, take your pawn, and attack your rook at the same time. So, huh. I'm not gonna overcomplicate it. I'll just win your rook. Ooh, that was a mouse slip. Damn. There goes my attack. I wanted to go here. That was awful. Oh wait, your knight is hanging. I just noticed that. Wait a minute. Did I just accidentally win? Yeah, now you're guarding that square. I know, but think about it. My queen was here. If I had gone here, he could have done something like I wanted to. He could have moved this here and then everything would have been over. Even if I moved there, that would have been a check. He might have moved here or here. No, he would have moved here. And then I would be lost again because I couldn't stop this. It might have been an accident, but it turned out good for me in the end. Anyway, let's see. Do I have any defense against this now? This takes. So yeah, I have that defended. I will lose my queen, but he'll lose both his queen and his rook if he tries to take that. Are you trying to win that? Forget, I am castling right now to guard this entire row. My queen is trapped. My queen is uber mega trapped. Time for a desperate move. Desperate at times call for desperate measures. Queen trade. Come on. Trade your queen. You take. I take. No queen trade. Okay. So, my idea was his queen takes. I take with knight. He takes with rook and I lose a knight. How? Okay, how am I just making these good moves? But based on completely faulty logic. Anyway, I gotta get my queen out of there. I'll do this next turn. And attack the rook, I guess. But I'll also threaten a check. With the bishop. Ooh. Proceed as planned. Take. I can deliver a check like this as well. Check. Hold on. Check. Check. King moves somewhere. King can only move here. Then what? Take? No. Check. Take. That's also a bad check. What if I check like this? Check. King can move here or here. And then I'm lost again. Check. Check. King move. I move here. That's my plan right now. I should start making faster moves. Oh, this is bad. This is really bad. I was saying I should start making faster moves just because otherwise I'm gonna run out of time. Um, right. The dark squares, they are not safe. Maybe I should have moved here to deliver a check with the bishop next. Fuck it. I'm just gonna do this. Then I'll check. Move the queen to the side this time. Then this. What are you attacking? What are you planning? I am just going to guard my queen because I am highly suspicious. He saw the bishop attack. The bishop attack is worthless. I just realized whether or not he saw it, that attack was worthless. I forgot that pawn was even hanging. Um, 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 uh, uh, Now my knight is hanging. It is trapped. My knight is not just hanging, it's straight up trapped. But none of that matters because I just want a rook. It doesn't matter that the knight is dead. Can't I do this? Hold on, I think I just have checkmate. Oh no, I blundered. I blundered my rook. Fuck. Alright, new plan. Checkmate with queen and bishop. I've never done that before. Let's go. Check. Try to deliver a mate with queen and bishop. Oh, that was awful. I almost lost my queen. I am making a lot of awful mistakes, but somehow I lucked out. That one was way too lucky. And the fact that he resigned was also lucky because I don't think I could have won with queen of and bishop. I think I might have gotten a stalemate with that. But yeah, this was a fun video. I learned a lot about C++, did some chess to unwind. That's it for, so I guess that's it for this video. If you like this video, be sure to leave a like, comment and or subscribe. Dislike it if you hated it. I'll heart your comment to let you know I've read them. So just because I hated your comment doesn't mean I agree with it or endorse it. And if you want more casual videos, please check out the main channel. I'm Zulk-BS and I'll see you next time. Goodbye.